Hi everyone, my name is Vila Kamore from Kagumo High School. I'm the school's professor and my role is to be in charge of the science club and to make sure that these great minds of science which are in this school have been nurtured and exposed to the world of science. So today I wanted to discuss about a topic in astrophysics, and that is the multiverse. And basically the multiverse is the existence of many universes. So to be able to understand the multiverse first, we must be able to understand where our universe came from. And as you all know, the most accepted theory on the existence of our universe is the Big Bang theory. This is a theory that explains that our universe began from a particle which contained an infinite amount of energy, and then it exploded in a Big Bang. And as we know from the Einstein's theory of relativity, mass and energy are interchangeable, which means that mass and matter are interchangeable. So when the Big Bang happened and that particle exploded, it sent all its contents of energy dispersing everywhere in space-time. And so they condensed over time. The universe is 15 billion years old right now. So within those 15 billion years, they condensed to form what we know as our universe right now. And an investigation was done by a scientist known as Alan Guth, and he found out that instead of gravity acting towards pulling everything together, it can also act in the opposite direction and disperse everything. From a particle as tiny as this, it can disperse the contents to the size of almost our solar system in a billionth of a second. So basically that's how our universe began. And you can just picture like a bomb. When a bomb explodes, it sends all the contents it contained dispersing everywhere. So here in the multiverse, so we see that's how our universe began. But now, taking the analogy of the bomb, the particles of the bomb, when it explodes, they are going to move, but they're not going to move forever. They move for only a short period of time, then they stop moving. But that's not the case, because in our universe, ever since the Big Bang happened, the particles have been moving over and over and over and over. The galaxies are still moving apart from each other up to now. And so that provoked the minds of scientists to think that there must be a force that is pushing these galaxies to be moving away from each other. There must be a certain force which is making the galaxies, the universe to expand, that is pushing the galaxies away from each other. And now because we don't know where that force originates from, we can't see it, we can only see what it is doing, they name it the dark energy. The dark energy is the force that pushes our galaxies, or the force that makes our universe to expand, pushing the galaxies away from each other, because in our universe currently there are like 100 billion galaxies which are known. One of them being the Milky Way galaxy, we have the Andromeda galaxy, and such. The dark energy, on further investigation, a mathematical calculation was done and gave a very weird figure of 1 times 10 to the power negative 24. This is the amount of dark energy in our universe. That is 0.1234, 23 zeros and a 1, the amount of dark energy in our universe, which is capable of pushing those galaxies moving away from each other. And so that is basically what happened to make our universe the way it is right now. And up to now, it is still continuing to expand. We don't know for how long it will continue to expand, meaning it's eternal inflation. Other scientists predict that it might expand, and just like the way it was expanding from a point source, it will reach a point of optimum, then start condensing again and form the particle again where it originated from. Then once again, the Big Bang will happen again, and the expansion, and the contraction, and that continues. That's what some scientists think.
Do you think this will be the end of the world? That corner when you condense?
Yeah, but the end of the world when it comes here.
All
this reasoning can be true.
All right.
But others think that it will continue expanding and expanding. So basically now in the multiverse, we think that this particle here, which exploded, it was contained in a space. And it does not make sense that in that space, which is very vast to occupy our universe, which is 15 billion light years. A light year means that if you travel at the speed of light, okay, for example, if you see 10 light years, it means if you travel at the speed of light, you take 10 years to go to that place if you want to go. So 15 billion light years, it does not make sense that our particle, this one, was the only one which was contained, and thus in this whole space here. So scientists came to think that maybe this particle might have been one particle out of very many others contained in the space. Very many of them, an infinite number of them. And the Big Bang, this act of explosion, is continuing to happen every now and then. So that now if this particle is exploded here, there's another one exploding here, and another one exploding here, and another one, and another one, and another one. So that one forms the basis of our multiverse, in short. So maybe there might be another universe here which has formed, maybe right now as we speak. There's another one which formed yesterday. And so in the end, you find that there are an infinite number of universes which are being formed in this space right here. And so that forms the basis of the multiverse theory. So looking at our Big Bang, we already said that there's this dark energy which is capable of pushing the galaxies towards each other. So when these contents here, they dispersed, due to the explosion, this amount of dark energy is the one that resulted to them being that some of them condensed to form our solar system. Others, they condensed to form other galaxies elsewhere, leaving this space here with nothing, or maybe nebula gases. So this amount of dark energy is the one which is responsible for our universe the way it is. So maybe if in another galaxy there's a different amount of dark energy, let's say for example more than this, maybe the solar systems will not be formed because this dark energy will cause those particles to move even further, so the galaxies will not be formed. But even maybe in another one there will be a very low amount of dark energy compared to this one, so that after the explosion had happened, the universe will not expand at the same rate as our universe. And so maybe in another universe somewhere, maybe the amount of dark energy is identical to the one in our universe here. So that's first forms the basis of the multiverse. But before we continue further, we must mention something known as the string theory. Yeah, the string theory. So as you all know, particles, they're made of atoms. The atoms, they contain neutrons, protons, and electrons. So if you go further into the protons and the neutrons, you find other smaller particles known as quarks. Yeah, this is not a syllabus or a topic in high school. It's in astrophysics. You can pursue it if you want when you computer school. Known as quarks. So in these quarks, further, scientists predict that there are other, not like particles, but they call them strings, like this. Very many of them, which are constantly vibrating. And their vibration is the one that gives the particles in our universe the properties that they have. The vibrations of these strings are the ones that cause the protons in our universe to be positive and the neutrons in our universe to be negative. So maybe if you go to another universe, the strings do not vibrate with the same frequency. So maybe the protons in this universe, they are not positive. Maybe they are neutral. Maybe the protons in this universe, due to the vibration of these strings, maybe they are negative, which is opposite in our universe. And that's why you might have heard people talking about something called the antimatter. Yeah, the antimatter. This is basically because of the vibration of the strings. In another universe, the vibration is different, causing the particles there to have different properties. And so as a result, the matter in that universe, it has different properties from the matter in our universe. So this dark energy, when you have the string theory. So these two theories, this concept of the dark energy and this concept of the string theory, if you can be able to think about them well, you'll see that they will lead you to one point. A point that will prove to you that just maybe the multiverse might be real. Because looking at the amount of dark energy, as I mentioned earlier, maybe there's another universe with a similar amount of dark energy as our universe. And so we already say that this amount of dark energy is one that resulted in the solar system being formed, and eventually to us being formed. According to the scientists, according to evolution, this amount of dark energy is the one which caused that. And so maybe there's another universe with a similar amount of dark energy. And so maybe there's another universe with a similar vibration of strings as our universe. So the matter is the same in both universes. So in the end, you'll find that there might be another universe which is just but identical to ours. And that's why you might have people say that there might be another you in another universe, which might be true according to the multiverse theory. Because if it has the same amount of dark energy, and if it has the same vibration of the strings, then it means that this universe, it will expand at the same rate as ours. The galaxies formed in ours will be formed in this one because the dark energy is the same. The matter is the same because the vibration is the same. And so the universe will end up being the same as ours. We can use an analogy, for example. If we have some cards, Those who like in cards. Let's say 4. Then this is, let's say like there's a joker, the queen, the king, 7, 2, and such. So if I had those 4 cards and I give you a certain combination, let's say I give you J, then K, or AK47. Let's say I give you a combination of AK47. If we shuffle the cards and we continue the process very many times, there's a possibility that we repeat the same combination again. So because these explosions of these very many particles in this whole space, they are continuing, they are random, and they are infinite, it proves that there's a possibility that the same explosion which caused our universe will happen again to cause another universe. The only distinguishing feature in both universes, or the only difference will be time. Because maybe our universe was formed today, let's say for example, then 20 years from now, or let's assume ours was formed in 2000, then 20 years from there, another one was formed. If this one is identical to this one is identical to this one, it means that this universe will just about be 20 years behind this one. So this is where I like to base my theory about time travel, because now we've already discussed about the multiverse, we've completed everything, the dark energy and the string theory, both leading to one point. So we can come again to another point and talk about the time travel. And time travel to the future, for example, it's very simple, because according to Einstein's relativity, the faster you move, the slower time moves. That is called time dilation. So if you move very fast, time will move slower for you, but in other places, the time will be the same, the norm. For example, if I move from here to Mars, and I go very fast, I take 1 second, the time on Earth will continue being the same. So I might go there with 1 second, but when I return, I've taken 2 seconds to go and come back from Mars. But when I return, I find that Earth is 1 year ahead of me, because the time on Earth was continuing constant, and my time was moving slowly because I was moving very fast. So that is basically, I'll have traveled to the future, 1 year to the future, because I'll just be 2 seconds older, but the Earth is 4 years, is 1 year older. So if I left somebody in high school, I'll find him in the university because it's already completed. But now, time travel to the past does not work like that, because time travel to the past, it means like if there's somebody in the future, there's a me in the future, he can come here right now where I am and find me here. And that does not make sense to me, that I can move from this Earth of ours and go to the past 20 years behind in the same Earth. That does not make sense. But it makes sense that I can move from this universe here, which contains Earth, then move to another universe which was formed 20 years behind our universe, and find the Earth as it was 20 years behind. So this is where I like to base my theory about time travel. Yeah, my theory about time travel. You simply have to move from our galaxy, from our universe, and go to another universe elsewhere where it was formed behind us, and there are very many universes. So that also means that you cannot keep traveling through time as if you own it. Because, for example, if this universe was formed 20 years behind, if there's no other universe which was formed here, let's say 10 years behind ours, it means that we're in 2022. It means you can't go to 2012, for example, because there's no universe which was formed 10 years behind ours. You can go here, but you can only go to here at 2002, where there's a universe which was formed 20 years behind ours. So you can't just go traveling through space as if you own it, or time as if you own it. So that's basically where I like to base my theory about time travel. And now the problem is, how do you move from this universe and come to this universe? Scientists believe that if you connect 2 black holes and another one here, you will form what is known is called a wormhole. Wormhole. Yeah. Wormhole. Basically, I think you must have seen it in movies if you love watching sci-fi movies. Wormhole. Like that. So if there's a way we could connect the black hole in this universe of ours here and connect it to another black hole in this universe of here, we'll form a wormhole, which is like a path that can help you to pass through it and come to the other universe the way you want it. And it might be possible, but now the problem is, how do you just combine 2 black holes? Because a black hole has a very the escape velocity of the black hole is more than the speed of light. You can't escape it. So you can't even come in a black hole. But maybe you can be able to create your own black hole. How? E is equals to mc squared. It means that energy is the same as mass and the speed of light squared. And it is proven that when you accelerate an electron, for example, when you accelerate it, it becomes very heavy. So a mass of even as low as 0.01 grams can give you a very large amount of energy, because 0.01 times the speed of light squared, a lot of energy. So maybe you can create your own black hole in this universe, and maybe I was thinking that maybe somehow it might form in another universe which is identical to ours. How? If this is our universe, this is one galaxy and this is the other galaxy, then our universe is expanding. The point is, the galaxies are moving away from each other, but the space between them is not moving. Let's assume at a point time x, the space was this size. So when the galaxies expand again, they were here and here. When they expand again, and then this one moves here and this one moves here, and so we can assume that now the space between them is now this. Then they expand again. You realize that this point here has not expanded yet. The galaxies are moving away from each other, but the space here is not moving anywhere. So maybe if you create your own black hole here, maybe somehow it is supposed to form in another universe, because this point is the same point in the other universe. The point is not changing, it's constant, it's not expanding. So maybe if you create your own black hole here, maybe it might be able to appear in another universe there. That's just my hypothesis. But anyway, that's about time travel. And in the future, I want to become an astrophysics, and I want to be able the person who inspires me is Albert Einstein. I want to be able to solve things like Albert Einstein did. For example, there's this the general theory of relativity. And for ages, very many years, we've always known that there's gravity. I'm sure you have heard about Isaac Newton and the apple, whatever, gravity. But Isaac Newton knew there's gravity, but he did not know where the gravity is coming from. But Einstein, with his good brain, came and realized that, suppose what we call space is not space, it's space-time. That is space plus time. Space plus time. To give you 4 dimensions. So he figured it out, like, we can assume it's like a sheet, like a blanket, for example. Let's say a sheet, like a blanket. So if you place a ball on a blanket, which is straight like this, the ball or the heavy metallic sphere will cause a depression. So that if it was like this, it now changes and there's a depression which is caused here, which is like this. So that ball is here. So if you take a smaller pebble and put it around here, instead of coming directly in here, it starts to rotate. So that's how Einstein explained gravity. And he said that gravity is simply a curvature which is caused in space-time. The analogy of the sphere and the pebble, they work the same. So that if this is the sun, it causes the depression. And our Earth, our small Earth here, maybe 50 times smaller than the sun, or more, our small Earth here will start rotating around the sun. Then this Earth, our Earth here, you can assume now this is the sun. Now our Earth here, it has caused its own depression here. The moon is smaller than the Earth. So the moon has also caused its own depression here and also starts rotating around the Earth, because the magnitude of the depression is directly proportional to the mass of the object. And that's why even astronauts, when they're in space and they're fixing their space ships, if they happen to have a screw which falls, instead of just going, it starts revolving around them because of the same thing. Because the astronaut has mass, so it creates its own kind of like a depression, although it's not very pronounced, its own kind of like a depression. And so the screw, because it's lighter, it starts rotating around him. So this is how Einstein basically explained gravity in its general theory of relativity. But still, there's another concept. called time dilation. I mentioned it earlier, which says that the faster you move, the slower time moves for you. And also, it happens that the stronger the gravity, the slower time moves. For example, time on Jupiter moves slowly than the time on Earth, because Jupiter has much more gravity than the Earth. That's why if somebody could approach a black hole, you will not see, you can even, when you're on Earth, you can see them as if they're not moving, because the time there on the around the black hole moves very slowly, so that from a perspective here, you will not see as if it's moving, because time is very slow there. So the stronger the gravity, the slower time moves. But I tried to research, why does this happen? And there was no explanation. And so I created my own explanation. For a very long time, we've always thought that time is moving. But suppose we are the ones who move in time. What do I mean? This here, you can assume is the sun. This is our Earth. It is moving in its own, I can say like a path. Because when the Big Bang happened, it set all these particles moving. So ever since the Big Bang happened, the sun has been moving on its own path. The Earth has also been moving on its own path. But you cannot see the sun moving, because the relative motion between them is the same. The relative motion between them is the same. So there's no way we can look at the sun and see it moving along its timeline, because it's like you have two cars. One is moving at a speed of, let's say they're moving at a constant speed, 20 and 20, but one is in front of the other. You cannot see this car moving, because the relative motion between them is the same. You take 20 minus 20, it becomes 0. So you cannot see them moving. And for the same reason, we cannot see the sun moving in its own path. But now, that path, suppose it's the one that dictates time, so that the sun causes a very large depression than our Earth. And so this one will make it, if this was its path, if it's moving in this path, it will make the movement of the sun will be slower than the movement of Earth. The same analogy, when you have a blanket and you put a very heavy sphere, then you start rolling it. Then you put a lighter one, then you start rolling it. The lighter one will move very fast compared to the big one. So this big one, the sun, because it has gravity, has caused a greater depression. And so this depression has been caused in space-time. And space-time is space plus time. So time is included in this thing, which I like to call it the path that it's using. That's why it will move slowly, because it's causing a depression through space-time, which will make it, the movements along its time path will be slower. And consequently, when you are on the sun, of which you cannot be, time will be very slow for you, because the movement of the sun along the space-time, which includes time in it, is very slow compared to the Earth. So that's how I like explaining why when you have gravity, the more there's gravity, the slower time moves. It's simply that a depression is caused to cause gravity. That one is verified by Albert Einstein. But again, space-time is simply space plus time to make it four-dimensional. Those things are dimensional. So there's a time path which the sun is following since the Big Bang happened. It's following that path as we expand our universes. So this path, we cannot see it, but it is included in the space-time. So this path, the movement of the sun along its path is the one that dictates time. Because the movement is very slow compared to that of Earth, that's why when you are on the sun, you see time moving slower compared to when you are on the Earth. Like, I think 8 branches of physics. You have the atomic nuclear physics, mechanics, optics, but you do not have a branch of physics that deals with time. There's no branch of physics that deals with time. So maybe I could even create my own branch of physics that deals with time, so that we can be studying time and understand time very well, because time, we think we've understood time, but we've not. They say that time is the duration of an event. So that event happening means that there's time there. The duration of the event is not the time. The duration of the event is there because there's time. So we cannot explain time as the duration of an event. A simple analogy. Right now I'm shooting a video. If somebody came and told me, let's go to the beach and play, I tell him, no, I can't. Because when I look at my watch, I can see that I'm supposed to be shooting a video right now. Then in the next 10 minutes, for example, I'm supposed to be going for lunch. So I just have 10 minutes in which I'm supposed to shoot the video. Then after the 10 minutes, there's no other time. I have to go to lunch. So I don't have some other few minutes between that. Meaning that I can't do the activity. That's why people say in the layman's language, says you sina time. As in, I just have 10 minutes from now until to when I shoot the video. Then after the 10 minutes, I have to go to lunch. Then if you come and tell me we go and play, there's no other time between here and me going to lunch. So I can't play because I don't have the time. So that's simply what happens. If there's no time, nothing can happen. If there's no time for the Big Bang to happen, it will not have happened in the first place. And who knows? Maybe this space which contained all our universes, maybe it's also one among very many containing another large one. Maybe the other large one is one among many containing another large one. So maybe the cycle continues, just like I might think that this is the end of the pen. I cut it into very small particles and I get a very small particle until I can't cut it further. So I think this is the end, but it's not the end. Because if I go deeper, I find molecules. Deeper, I find atoms. Deeper, I find protons and neutrons. Deeper, I go and find quarks. And deeper, I find strings. So maybe that's the cycle. It goes on increasing and increasing and increasing. So if you have any comments or question, yeah, you can ask below there. So thank you for your time. Hope you enjoyed.
Where did you learn all this?
I did research online because I use my phone very well. So when I go, I try to do research. There's one scientist who I follow very much. It's called Brian Greene. He explains these things dealing with time travel and such. So I did the research and I thought that it might be clever to come and explain to people here, because people think that when they hear about the multiverse is that there are very many universes which are identical, which is not what we have seen here. People also come and think that you might find another villa in a place, but that villa in that place is a robber, for example. So that cannot be me, because the reason I am me is because of my character and the decisions I make. So if there's another villa, someone who is a robber, in his mind, the memories he has is just about how he's been doing his robbing stuff. And my memories are how I did this science stuff. So even though we are identical, we might appear to be identical. That cannot be me, because you have two twins who are identical. The reason you say this one is this and this one is this is because this one has different characters from this one. So that cannot be me. But maybe if there's another universe which is the same as our universe, now the villa in this universe should be the same to the villa in this universe. That's why I base my theory of time travel here, because if I come 20 years, okay, I wasn't born by then. If I come 15 or 10 years behind, another universe which was formed 10 years behind ours, I should find myself as I was 10 years then. But again, changing the past does not change the future. What do I mean? If this is our universe, then I come to this universe. If I change what happened here, it will not affect what is happening here right now. If, for example, I come in this universe, then I do a major change. For example, if there was a world war, for example, then I go and kill all the people who started the world war. This one will not change the fact in this universe that the world war happened. Instead, what will happen? This universe will not follow the same future. It will have a different future in the end. So changing the past cannot change the future, basically. So yeah, I do research online and read a lot of books, a lot of them.
Yeah, do you watch movies?
Yeah, I watch movies, but I just like watching sci-fi movies, like Spider-Man, Way Home, Multiverse of Madness. Yeah, the movies that deal with this and stuff, because people think that the science borrows from the movies, but the other way. The movies borrow from science. So all these things you see in the movies, the sci-fi movies, time travel, they have a truth. There's a truth behind it when you come to science and physics. Yeah.
Wow. Do you have any questions? Some you've not understood Kitu. Do you have any? Yeah? Do you have any question? Yeah. So what does that make you feel about him?
He's not there. I can say he's a teacher. He can be a teacher. But he's born to fly. He goes to study for astrophysics.
Yeah, he will. Yeah. Where can you do that? Astrophysics.
Astrophysics?
Yeah.
I aspire to go at MIT.
MIT, just like Carl.
Just like Carl.
Carl says you'll go to MIT. MIT.
That is the best university
Yeah.
in the world, around us, which is concerning physics.
Yeah,
Science.
and Carl was your friend.
Yeah, he was my
What
friend.
can you say about him?
He was a very good guy because we were bedmates actually in the same house.
Yeah.
And when we met, like we shared a lot in common. We both loved science, and so he mentored me very well. He's my role model, and he's a good person. Even when we won it with Spark,
Yeah.
that gives me some. I think I can also make it to there because I think, yeah, I think he's just a good person.
Yeah.
Just
I think you are too.
Yeah, thank you.
You'll make a great scientist,
Amen.
physicist.
Yeah, physicist.
Yeah. Yeah, so thank you so much for your time.
Yeah.
Tell them to like and subscribe.
Yeah, so you like the video, you can like and subscribe by clicking that. Yeah. And
Yeah.
if you have comments, you can comment below there, questions, and also ask us.
Yeah.
Yeah.
All right. Thank you.